We've covered the basics of the @component decorator in the quick start. We explained how decorators work and both the template and selector configuration properties of the component decorator. In this lecture, we're going to go through a number of other configuration properties, including template URL, styles, style URLs, and encapsulation. And in a later section on dependency injection, we're going to cover two other ways of configuring components with the providers and view providers properties. So starting with template URL. We don't have to write our template code in line with our component code. We can store our HTML template files separately and just refer to them in our component by using the template URL property. So using the joke application we built in the quick start, let's move the template for the joke form component to a file called jokeformcomponent.html. So firstly, let me copy the HTML. In Plunker, to create a new file, we click New File. We give it the name of the file we want to create. And it creates it and opens it for us. I'm going to paste in the HTML. And then let's go into our script tag, in our script TS file, sorry. And the property changes to template URL. And then we give it the path to the HTML file. We can also specify any custom CSS styles for our component with the styles property. So styles takes an array of string, and just like template, we can use multi-line strings with backticks. So let's define a style for the joke form component so it gives it a background color of gray. So just to make sure it's clear, styles takes an array of styles. And each item in the array can have any number of CSS selectors inside it. We're just defining one item with one style. So now if we run our application, we can see that the form component now turns gray. Even though we changed the background color of the card class to gray, and we have multiple cards on the page, only the form component card was rendered with a gray background. So this card class here is being used for each of these jokes as well. But even though we've set the background color to gray, only the card that's used in the joke form component is set to gray. Now normally if we change a CSS class, the effect is seen throughout an application. So something special is happening here, and it's called view encapsulation. So Angular is inspired from something called web components, and a core feature of web components is the shadow DOM. Now the shadow DOM lets us include styles into web components without letting them leak outside of the component's scope. So we've included a style of a background color of gray for the joke form component, and through view encapsulation, it's not leaking out to the other components, to the other cards on the page. Angular provides this feature for components, and we can control it with the encapsulation property on our component decorator. And the valid values for this property are native, emulated, or none. And the default value is emulated, and that's the behavior that we're currently seeing. Let's inspect the form element with our browser's developer tools to investigate what's going on. So if we look at the DOM for our joke form component, we can see that Angular added some automatically generated attributes. So specifically, we've got one _ngcontent-xrb-3. If we take a look at the other components on the page, specifically each joke, we can see that they don't seem to have these automatically generated attributes. Only the joke form component has these attributes. And that's the only component where we have specified some styles. And then if we look at the styles tab here, we can see that a style is set for our special attribute, our attribute of ng content xrb3. And this is the style that we've set with the background color of gray. So Angular set this CSS style, and because it's only targeting attributes with ng content xrb3, it's only targeting the joke form component. So what happened is with the emulated view encapsulation mode, Angular changes our generic card CSS class selector to one that targets only the joke form component. This is the reason that only the joke form component is grey, despite the fact that we use the same card class for all the other joke components as well. Any styles we define on a component don't leak out to the rest of the application. But with view encapsulation emulated, our component still inherits the global styles from Twitter Bootstrap. So even though we customized the style of card, that customization is only visible for the joke form component. The joke form component still gets to inherit all of the styles from the application itself, from Twitter Bootstrap. So if we want Angular to use the shadow DOM, we can set the encapsulation parameter to use view encapsulation native. So to do that, we simply, let me get rid of the console there. We simply add another parameter to our component decorator, and we make it equal to view encapsulation native. Now, just like everything in Angular, we will also need to include or import the view encapsulation code. So let's import that at the top. Now it's actually from Angular core at the top there. So now we're using view encapsulation native. Let's restart our application and see what happens. But now if we look at the application, although the background color of the joke form component is still gray, we've lost the global Twitter Bootstrap styles. So just like view encapsulation emulated with view encapsulation native, styles we set on the component do not leak outside of the component scope. So just like before, the other cards, they're still not gray. So the style we set by setting the card of gray, it's only applied to the joke form component and it hasn't leaked out to the other components. So this is great if we are defining a third-party component, which we want people to use in isolation. We can describe the look and feel for our component using CSS styles without any fear that our styles are going to leak out and affect the rest of the application. However, with view encapsulation native, our component is also isolated from the global styles we've defined for our application. So we don't inherit the Twitter Bootstrap styles and have to define all of the required styles on our component decorator. And finally, the view encapsulation native requires a feature called the shadow DOM, which is not supported by all browsers yet. And if we don't want to have any encapsulation at all, we can use view encapsulation none. And when we run that, we can see that now all the cards are gray. And if we investigate with our browser tools, we can see that the background color has been set, but just on the card selector. And it's actually just been inserted into the HTML page as a style tag on the top. So we are not encapsulating anything. The style we define in our card form component has leaked out and started affecting all of the other components as well. Let's take this off again. So like the template URL property, with the style URLs property, we can externalize the CSS for a component into another file and include it in. However, like the styles parameter, the style URLs parameter takes an array of CSS files. So let's do the same for our joke form component. So let me copy our CSS style here. Create a CSS file. Paste our CSS in. and then provide the path to the CSS file. And if we run it again, we can see it's pulling in the CSS from the CSS file. So in summary, we can externalize our HTML template into a separate file and include it with the template URL property. We can also define styles for our component via the styles and style URLs property. By default, styles for our component are encapsulated. That means they don't leak out and affect the rest of the application. We can explicitly set the encapsulation strategy using the encapsulation property. By default, the renderer uses view encapsulation emulated if the view has styles, otherwise view encapsulation none. There is also a view encapsulation native method which uses the shadow DOM to encapsulate the view. In the next lecture, we're going to look at a feature of components called content projection.